friends, welcome to Electronic Circuit Hub. So today we are going to understand about the dual output buck converter. Let us say you have the requirement of two output voltages, and in spite of using two different two buck converter circuitry, you want to design the buck converter by using single IC. Okay, IC or single switcher IC. How you gonna do that? That means how you gonna design the two output buck converter. So let us understand how you're gonna design that. What is your input requirement? What is your output requirement? And how this whole circuitry works, right? So if you look at here, the input voltage. So the input voltage for this design is 24 volt and the output is 5 volt 5 amps. That means one output I am getting 5 volt 5 amps. That means 25 watt, and the other output is 12 volt at the rate of 5 ampere. That means I want 60 watt, right? So simple circuit, one IC which is giving two output voltage. One is 5 volt and other one is 12 volt. And let us say my input is 24 volt. And if you look at now the circuit here, so this is the complete IC, and here I have the 20 input voltage which is 24 volt. Now if you look at in the buck converter, what is the simple discrete component of the buck converter? Okay, so in buck converter, in series with your input, you will have your switch, that is MOSFET, and then you will have your this you can call Q1 as a high side switch and Q2 as a low side switch. So this is synchronous rectification, synchronous buck converter. So that is why I'm using here a MOSFET, not a Schottky diode. But if you look at in parallel with the MOSFET, I'm using the Schottky diode. The reason to use this Schottky diode is to provide the dead time, ample dead time. Okay. Then you have VCC, you have the MOSFET, your switching MOSFET. Then here you have the freewheeling MOSFET, that is Q2, and then we have the inductor, and that inductor is connected to your output voltage. So that inductor, and I want to measure the current of my buck converter. That is why I have used R8. This measure the current internally. This buck converter IC is having the sense 1 pin and sense 2 pin. That means it is measuring the current of your buck converter. And then this is my output capacitor C4, and I have connected the load of 1 ohm. Okay, I have connected the load of 1 ohm. That means this is my 5 volt 5 volt 5 ampere output. Now if you look at, we call it as out 1. This is your out 1, right? Now this also goes to the feedback pin or sense pin. If you look at here, VO sense 1, so this is the feedback pin. Sense 1 plus, sense 1 minus, this is the current sense pin. This is the switch driving pin, okay, the switch pin. And here you have the TG1, the gate driver, and the boost trapping circuit boost 1. If you look at now, if you go at the other side, so V1, and again I have one MOSFET. V1 in series with V1 you have the MOSFET, and the gate driver for the MOSFET, that boost trapping circuit, we call it as a boost true. The diode D4 and C4, this is for Q3 and Q1 we require high side driver, and for Q2 and Q4 we do require low side driver. And again the inductor, here if you look at, the inductor is 15 microhenry, and then output capacitor and the load resistance. Here I'm getting 12 volt 5 ampere of output. Without delaying any time, let us run the simulation and see the different waveforms now. So directly I run the simulation, and let us look at the waveform. Okay, so go at window, tile window vertically maybe, and this you can zoom fit. Okay, so let us see first input. So this is my input, and input, if you look at here, it's 24 volt. Now let us see the gate to source signal. Okay, so this is my gate to source signal. Okay, here if I look at gate to source signal to this channel, this is again my gates to source and its signal. They are both opposite in phase if you look at. Okay, also the duty cycle is not same for both gate to source signal. Duty is not same, and they are also in the opposite in the phase. Okay, now if you look at, the switch voltage, you can see this is my switch voltage, and this is also my switch node voltage. Okay, so you see the difference in the duty for both switch voltage. And now let us look at the inductor current. Okay, this is my inductor current, and for other output, let's look at the inductor current. This is my inductor current, and if I zoom this now, if you look at the steady state inductor current, in both cases IL1 is the inductor current for 5 volt, IL2 is the inductor current for 12 volt. And if you look at now, IL1 is in green, IL2, let me change the color to maybe red. Okay, and this also you can change the color. I want to change the color to, let's say, blue, so that proper you can see. Okay, here we go. So IL1 is the 5 volt, and at the 5 volt you see the ripple current of inductor is higher if you compare with the IL2, the 12 volt output. Okay, 5 volt output, the inductor ripple current is higher than your 12 volt output. Okay, 12 volt output. Now let us look at the output voltage and current. So this is my 5 volt output. So if you go and look at, this is my 5 volt output. Okay, and if you look at now the 12 volt output, let's see the 12 volt output. This is my 12 volt output. Okay, if I move the cursor around here, this is my 5 volt. Clearly you can see the 5 volt here. We do have some ripple voltage, you can see, but it's 5 volt. And if you look at the here, we are getting 12 volt. We do have the ripple voltage here as well. We do have the ripple voltage, but it's 12 volt. Now let us look at the output current. So I click it here and I click it here. So now I have my two output voltage, V out 1 and V out 2, and I have the load current IR load 1 and IR load 2. And if you look at both load current is 5 ampere. That means for 5 volt I am getting 5 amps, and for 12 volt I am getting I'm getting 5 amps current. So either cases, for 5 volt the current is 5 amps, that means 25 watt. For 12 volt the current is 5 amps, that is 26 watt. So by using single IC and external components like MOSFET, we are getting two output at the same time. We are delivering the 25 volt output by one channel and the 60 watt output by other channel, that is out 2. Okay, so here you're getting two outputs. And what else we can see, if you want to check the sense current, that is how it looks like. This is your sense current. Okay, if you want to check the sense voltage, we can check the sense voltage, that's not an issue. So sense current and sense voltage, if you see lots of ripple here at the sense voltage and sense current. And if you want to look at the switch node voltage again, so this is your switch node voltage, and the amplitude for your switch node voltage is starting from 0 to 25 volt to your input voltage. Whatever input voltage you have, that is the maximum switch node voltage for your buck converter, right? So you can use this kind of circuits to design the dual output or two output buck converter